For our penny lab, we wanted to examine penny brightness by comparing the average color across the face of each penny. We chose brightness as our penny characteristic because we thought it was interesting due to the fact that we've all seen pennies with a variety of different colors.
However, these variations aren't due to differences when they were made, but rather mainly due to the amount of usage the penny has received. We believed observing the average color of each penny would result in an interesting and unique data set.
Select a camera whose settings will not auto-adjust during the data collection process. Choose an environment whose lighting will not vary during the remainder of the experiment. Set the camera phone up on an elevated surface and place a piece of white paper below it. Separate the pennies into 5 groups of 10 and place the first group on the piece of white paper. Mark the placement of the first group of the pennies so the following groups are placed in the same positions. Take a picture of each group of pennies. Repeat for the next 4 groups of pennies. Open up the picture of the first group in Photoshop and choose Image, Mode, Grayscale. Use the elliptical marquee tool to select one penny in the picture and choose Filter, Blur, and Average. Use the eyedropper tool to determine the RGB value. Each of the 3 fields should be the same number since the image is grayscale. This number indicates the brightness of the penny. Record the RGB value in the spreadsheet. Repeat this procedure for each penny in the picture. There should be 10 values per picture. Repeat this procedure for the rest of the 4 pictures.
Nice.
We considered modeling our data with a normal distribution because we wanted to represent a single real-valued random variable. The random variable in our case was the brightness of each penny.
We also considered an exponential distribution because the dirtying of, and therefore the brightness of pennies, seemed like a homogeneous Poisson point process. After further research, we found that an exponential distribution requires a rate parameter. We picked pennies at random from various locations, and the life cycle of each penny is an inherently random process. No 2 pennies are circulated in the exact same way or experience the exact same circumstances. This means no rate parameter exists for penny brightness, and therefore the exponential distribution is not appropriate for our data.
We plotted our data using a histogram because we wanted to visualize the frequency of each brightness value in our data set. Our histogram appeared to be a right-skewed distribution, probably due to the fact that most of our pennies have been in circulation for more than 10 years. This is backed by the fact that our mean is greater than the median and the mode values, which is a sign of right-skewed distribution. On a normal distribution, these values would have all been equal.